Calculus kids, this is Dr. Callahan with Week 10 Monday. How are you guys doing? Happy Monday to Week 10. Go ahead and pause your video and answer the following 3 questions on your brand new warm-up log. Now, if you don't have your warm-up log turned in yet or you don't have the new one, it's okay. You could just answer on the extra page on the back of your blue one because you do have an extra page that you can use. And you can just rip that one off when you turn in the blue one when I see you next class, and then keep the extra blue one and just staple it to the new Week 10 to Week 19 warm-up log, which is going to be in pink. Okay, let's go ahead and create the assignment for today, you guys. So this is Week 10 Monday. Calc AB Semester 2. And today we're going to talk about differential equations. And for day 3 on this topic. Make sure you guys watch the video in its entirety. Check in with me by 9:41 for Monday. And upload your assignment by Monday, 3 p.m. Okay, so with that said, let's go ahead and take a look at the breakdown of what we're going to be doing today. So we're going to talk about, actually, I'm not even going to show you guys this. This one is a little bit crazier to look at. So we're just going to go down to Week 10 Mondays, guided notes on your white packet. And the notes that you should have looks like this. All right, so you're going to start off with page 1. And I gave you like a series of examples here. And then this page right here is where we're actually going to be taking the look at the notes. So make sure you guys have this. And with that said, let's go ahead and get started. All right, go ahead and read the 3 different steps right there and also the 4 different examples. All right, let's go ahead and get started right here. So number 1, direct proportions speaks to you about y is equal to k times x. Inverse or indirect proportion is y is equal to k over x. K is called the constant of proportionality. So let's take a look at the first one. Now, we've done this before last week, and we basically started off with the integral of y is equal to integral of k times y. And ultimately, we got to the point where you have an equation, and that equation is y is equal to ce to the kt. Do you remember doing that? And so this formula is the formula we use whenever we do something that is directly proportional to it. So with that said, let's go on to example 2. And if you need the steps from last week, because we did go over this one together in class, here are the steps for that. Okay, example 2. It says the rate of increase of a population in a certain city is proportional to the population. If the population in 1930 was 50,000, 1960 is 75,000, what is the expected population in 1990? All right, so first things first, I'm going to look at this and go, okay, so when t equals 0, we start the year at 1930. So time, year, and population. So t equals 0, year is 1930, the population was 50,000, okay? Then in 1960, so the difference here is 30 years, the population was at 75,000. And then in 1990, which means T, the difference here is going to be 60, I need to know what the population is. So that's kind of how I'm breaking it down. All right, so you know your P prime is equal to K times P. So if I were to change P prime, that's going to be dP over dt is equal to K times P. But remember, you need to go ahead and ensure that you have the P's on the left side, the T's on the right side. So let's divide it by P on both sides and multiply dt on both sides. So dt cancels, dP over P is equal to K dt. And you're going to go ahead and integrate both of these. Integral of 1 over P is just ln P equal to K T plus C. I want to put X, but we're not doing X, we're doing T now. To get rid of the ln, we're going to put the E on both sides. Ln E cancels. P is equal to C E to the KT. Now that I have my formula, I'm going to use my first point right here, plug it in to find C. So when T is 0, population is 50,000. So 50,000 equals CE to the K times 0. Now, you know that K times 0 is 0. E to the 0 is just going to be 1. 1 times C is just C. So C is 50,000. You're going to go back to your original equation, rewrite it, and you should have that new equation as P is equal to 50,000 E to the KT. Now I'm going to use this equation to use the second point right here to find K. So in this situation, your population is 75,000 equals 50,000 E to the K, T is 30. Divided by 50,000 on both sides. And 75,000 divided by 50,000 is 1.5 equals E to the K, or 30K, I should say. We're going to go ahead and do ln on both sides. So have ln 1.5, E and ln cancels equals 30K. Divided by 30 on both sides, K is equal to ln 1.5 divided by 30. So then with your calculator, you're going to go ahead and plug the ln 1.5 divided by 30 in there, and then you should get K is equal to 0.0135. So now that you have your K and you have your C, you're going to take that and plug it back into this equation. So P is equal to 50,000 E to the 0.0135 T